Welcome to the tutorial on research. Today we are going to learn about the selection of appropriate test in quantitative analysis. I mean, what kind of test you should apply in what situations. That kind of idea you will get from this tutorial. As you can see, whenever your data is normal, then you have to apply one kind of test. But whenever your data is non-normal, you can apply another type of test. Then if you have a question what is normal data, then I can say that normal data refers to the data that follows normal distribution. I mean, the normal data is characterized by a bell-shaped curve. On the other hand, the non-normal data does not conform to a normal distribution. There may be high skewness. I mean, the data may be lean to one side, or maybe there is a high kurtosis. I mean, whenever the data have heavier tails on both sides. So whenever your data have outliers, in that case there is a possibility that your data is non-normal, and normal data will represent in a bell-shaped curve. Normally there will be no outliers in the normal data. However, as you can see, whenever the data is normal, you can apply independent sample t-test, paired t-test and ANOVA test for comparing means. And whenever the data is non-normal, you can apply the Mann-Whitney test, Wilcoxon signed rank test or Kruskal-Wallis test. So as you can see, if your data have two independent variables, and if your data is normal, then if you want to compare the means of two independent variables, and if your data is normal, then you can apply independent sample t-test. But if the data is not normal, then you have to apply the Mann-Whitney U test. But if your data has three or more groups, you want to compare the means across the three or more groups, then you can apply analysis of variance, which is shortly known as ANOVA analysis. In the same way, if the data are not normally distributed and you want to compare the three or more groups, then you can apply Kruskal-Wallis test. That means whenever comparing the means of two independent group, independent sample t-test, three or more independent group, ANOVA analysis. But if the data is not normal, then apply the Mann-Whitney U test instead of independent sample t-test. And if the data is normal, apply ANOVA, otherwise apply Kruskal-Wallis test. Now, if you want to compare the means of two related groups, I mean, if you want to know the before and after effect between two related groups, then you can apply the paired t-test. But the paired t-test should be applied whenever the data is normal. But in case of non-normal data, you can apply the Wilcoxon signed rank test whenever you are going to check the before and after effect. We apply the independent sample t-test whenever you are going to compare the two independent groups, as per example, comparing test scores between male and female students. On the other hand, you can apply the paired t-test whenever you need to compare the means of two related groups, I mean before and after effect. As for example, measuring the blood pressures before and after administering a new medicine to the same patients. On the other hand, you can apply the ANOVA test whenever you are going to compare the means value of the three or more groups. We can see there are two kinds of ANOVA, one-way ANOVA and two-way ANOVA. We apply the one-way ANOVA whenever we compare one independent variable across multiple groups. As per example, whenever you are comparing math scores among students from three different schools. On the other hand, we can also apply two-way ANOVA whenever we need to examine the effect of two independent variables on a dependent variable. As for example, whenever you are examining the impact of diet and exercise level on the weight loss, that means diet and exercise level are two independent variables and you are going to measure the impact on the weight loss. So in summary, whenever comparing the mean value of two independent groups, independent sample t-test, three or more independent groups, ANOVA, and before and after effect, paired t-test. But if there are non-normal data, then you can apply Mann-Whitney U Test instead of independent sample t-test. You have to apply Wilcoxon signed rank test instead of paired t-test, because whenever the data is non-normal, and whenever the data is non-normal, you have to apply the Kruskal-Wallis test instead of ANOVA analysis. These are the tests you have to apply whenever the data is continuous. But if the data is categorical, then you have to apply chi-square test or Fisher's exact test. I am repeating, these are the tests you can apply whenever the data is continuous or ordinal. But in case of categorical data, you have to apply chi-square test or Fisher's exact test. So whenever you need to test the association between two categorical variables, and if the sample size is large, then you can apply the chi-square test. But if the sample size is small, then you can apply the Fisher's exact test. So this chi-square test or Fisher's exact test are applied whenever you are dealing with the categorical data. But in case of continuous data, you can apply this independent sample t-test, paired t-test, and ANOVA test. But there is a significant difference that whenever the data is non-normal, you can apply Mann-Whitney U Test, Wilcoxon signed rank test, and Kruskal-Wallis test. So here the first 6 tests are applied whenever the data is continuous. But whenever you are dealing with the data of categorical variables, then you can apply the chi-square test and Fisher's exact test. But normally we apply the chi-square test whenever the data is categorical and large sample size. And if the sample size is small, then you can apply the Fisher's exact test whenever you are comparing the two categorical variables. As for example, whenever you need to examine whether the smoking status is related to the heart disease, I mean yes or no, here the smoking status may be smoker or non-smoker. So it's a categorical variable. That's why you have to apply the chi-square test. But the condition is the sample size should be large. On the other hand, if the sample size is lower, then you can apply the Fisher's exact test. As for example, if you want to examine the relationship between a rare disease and a specific genetic mutation present or absent when the sample size is small, I mean maybe 10 patients or 20 patients. So in case of categorical variable, we apply the chi-square test and Fisher's exact test. But if the sample size is small, apply the Fisher's exact test, and if the sample size is higher, then apply the chi-square test. Now we can see whenever your data is normal and you want to know the correlationships or associations between two continuous variable, then you have to apply the Pearson correlation coefficient, I mean Pearson R test. On the other hand, if your data is non-normal or ordinal, you can apply the Spearman's rank correlation, I mean Spearman's row test. That means if you have a intention to find out the correlations or associations between the continuous variable, and if your data is normal, then apply the Pearson correlation, I mean Pearson R test. On the other hand, if your data is non-normal and you want to know the correlation, then you have to apply the Spearman's rank correlation test, I mean Spearman's row test. Now as you can see, there are several types of regression analysis to know the causal relationship between the independent and dependent variable. If your data have one independent variable and one dependent variable, and if your data is continuous, then apply the simple linear regression. On the other hand, if there are multiple independent variables, in that case you have to apply the multiple linear regression. But if your dependent variable is dichotomous or binary, I mean yes or no, so that kind of dependent variable you have to apply the logistic regression. I mean, whenever the dependent variable is dichotomous or binary, then in that case you have to apply the logistic regression. And whenever you are going to test the causal relationship between multiple independent variables, then you have to apply the multiple linear regression. On the other hand, if you want to examine the causal relationship between one independent variable and one dependent variable, then you have to apply the simple linear regression. So these are the tests you can apply whenever you are going to do the quantitative analysis. Thank you.